common between 36 and 81?
9.
9. Okay, so what we can do is we can write that 9 on the outside. Okay, the way you find out what's left is to take your GCF and divide it by the parts that you have on the inside. Okay, so you can take 36x squared and divide it by 9, and what do you end up with? Okay, and you can take 81 divided by 9. What do you end up with? 9. Okay, so what do you notice here? Is you have your GCF, you have your what's left. Is your what's left factored completely?
Nope.
No. Now, again, remember, don't make things too hard. You're talking a difference of 2 squares is just 2 squares separated by a minus sign. Do you have that here? You need to bring the 9 down.
Yes.
Yes, we always need to bring the 9 down. Because at the very end of this, your answer should be able to be multiplied back to where you started. Okay? It needs to multiply back to where you started. If you leave out the 9, you're not going to get all the way back to the 36x squared minus 81. Okay? You just get stuck at the 4x squared minus 9 part. Okay, now how you factor a difference of 2 squares? 2 binomials. Okay, what do you know about the 2 binomials? The signs are different. Okay. How do you first term of the binomials? Okay.
2x.
2x. How'd you get 2x?
4x squared, 2 is the square.
Perfect. So 2x, 2x. Okay. How do you get the second part?
The square root of 9.
Which is?
3.
3. Because that's what you're doing. When you're factoring a trinomial, basically all you're doing is you're unfoiling something. Okay? You're taking something from its put together form and you're pulling it apart again. The way I explained factoring to one of the other classes was, think of it if you go and buy a table from IKEA. Okay? What you do is when you get that table from IKEA, how does it come? In a box. And in that box is 1,000 parts, right? So what you do is you take it over, you rip over the box, you open it up, you lay all your pieces out on the floor. That's basically starting like multiplication. And then you put it all together and you make a table. Usually there's some leftover pieces, which there shouldn't be, but you have some sort of resemblance of a table, right? That's what you get. That's what multiplying is. It's taking the pieces and multiplying it, putting it all together, and coming up with one piece. One giant piece. That's your table. What factoring does is it takes that table and it takes it apart. You know, say you're moving, you're going to college, and you want that table, you want to take it with you. You know, you took all that time to put it together. What you have to do is take it apart. Okay? So you have to take that one piece and break it up into a simpler form. All right? Make it small, break it up. That's all this is. So multiplying, that's why it's important. A is 1 is you factor it into 2 binomials. Okay? The leading term of the binomials is always going to be just x, or whatever variable it is you're dealing with. Okay? Now we talked a little bit about signs. Okay? Some of us got a little confused with the signs here. Let's make sure we're good. What sign do we check first? The last one. Okay? And when the last sign is in this case what? Negative. What does it tell us about our 2 signs?
They're different.
They have to be different. Okay? They have to be different. And again, understanding foiling understands why they have to be different. In order to foil, first, outside, inside, last. In order to get this last term, which is negative 84, you have to multiply 2 numbers together. What's the only way you can multiply 2 numbers together and get a negative answer? Is if they're what? Different signs. That's why we put the different signs in. It doesn't matter plus or minus plus. You need different signs. Okay? Now you think, well, what factors of 84 whose signs are different are going to give me negative 5? You go through your work, you list your factors, and you come up with what? 42.
Negative 12 and 7.
Negative 12. Now, does it matter if you write x plus 7, x minus 12? Or x minus 12, x plus 7? Why doesn't it matter? Because you're multiplying. Does it matter if you do x plus 12, x minus 7?
Yeah.
What's the quick way to check this? The long way is to FOIL. What's the quick way? And we learned a little shortcut. 8.
It has to equal the term in the middle.
What has to equal the term in the middle, and what operation makes it to that term in the middle? Because you're right. Something has to give you the middle term.
The two, what do you,
You're right. Say it. Say it.
numbers?
Two numbers have to do what to them?
That's add
Add up or combine. Sometimes I say combine because you don't want to distinguish. You don't want to say always add, always subtract. Because 7 minus 12. If you write 7 plus 12, you get the same answer. I mean, you're always adding, but in terms of combining, that's all you're going to do. 7 minus 12. It should give you the middle term. Okay, 7 minus 12 gives you -5. What's the second part to this? Second part. Second part to check.
Multiply the two numbers to equal the last one.
Multiply the two numbers to equal the last one. So what that means is positive 7 times -12 is going to give you -84. Okay? So there's no GCF. Now we're talking trinomial. So what we're going to have to do first is AC method says we multiply the first and last terms together. Okay? Which means we're going to multiply that 3 and the 8 together. And that'll give us 24. What kind of 24 we get? Positive 24, okay? Now, what that tells you is, once you're at this step, you do the exact same thing you did for number 2, except you use 24. So you're going to say, what factors of positive 24 when, whose signs are what? The same, are going to give you -10. Okay, so that's your thinking here. So what I like about the AC method as opposed to some of the other methods that people do is because it works right off of what you already know about factoring trinomials. There's not a difference. Okay, your mindset, your thinking in terms of the signs, it's all the same stuff. Okay, you use GCF in this method. All right, but there's steps to this. All right, so we should be okay. So we get 24. Now this is where some people got a little jammed up with this. What factors of 24 whose signs are the same give you -10? A lot of pressure. Brian, did you get an answer?
For the second, I put 3x squared minus 12x plus 2x plus 8.
Now, that's okay. Now, let's think about this, though. What'd you say? Minus 12x plus 2x. What's -12 times positive 2? No, just answer the question.
-12 times positive, that's -24.
-24. See where that doesn't work? What do those two numbers in the middle have to multiply to? Positive 24. That's why we said our signs need to be the same. Okay? That's why we said our signs need to be the same. So what factors of 24 whose signs are the same are going to give us -10? -6, -4. And you were right with the other parts. Okay? In terms of you leave the first part and the last part the same. Okay? All you're doing, and you're not replacing a value. You're not adding more in than what you started. You're just rewriting that middle term with two numbers that add to it. Okay? In terms of checking your work yourself, the two numbers in green, do they still add to that middle term? They need to add to that middle term. In terms of the end of this and checking, the only way you can check your work with the AC method is to actually go back and FOIL. There's not like a quick way to do it like before, but you can check yourself while you're going. Okay? Make sure that these two numbers give you that. It should work, and we'll get to the next check in a second. All right, but before we do that, I think that was the main part people were having. I think everybody was getting the AC method down. Okay, most of the people were doing good with that, but I saw a lot of people getting -12, positive 2. Okay, when that would have been right is if it was 3x squared minus 10x minus 8. Then you're all on. Then we're all good. Okay, but this is what we're dealing with. Okay, so what we do next is we split it. Okay, once we split it, now we factor each side. We factor each side using the GCF. Something we all know, something we all love. Okay? What's the GCF on the left side?
3.
3 what? 3x. Good. What's left?
X
Mm-hmm.
minus 2.
Perfect. Okay? That's fine. What's the GCF on the right side?
2.
Oh, even bigger.
Just kidding, 4.
4. Okay, now, and I'm not surprised that we didn't remember this part, but you have to be careful. Yeah, -4. If the leading term is negative, your GCF is negative. Okay? So we factor out -4. And Kelly, what's left?
X by -2.
Now, why is this good for us? It's good for us. To the best of your knowledge in terms of remembering what we did. Why are we in a good spot right here? Ah, perfect. So these two have to be the same. If they aren't the same, what'd you do? Made a mistake. One way to check yourself, now just based off of what Kelly was saying, if this is what we were at, and she just factored out a 4, what you'd be left with is -x, let's see, plus, no, not 2. Now, this is where you see your problem, is what Crystal just said was, those inside signs should match, right? That's what she said, the inside signs should match. Does that match that? No. But what do you notice about those two? What's similar about them? What's similar about x minus 2 and -x plus 2?
It's just the negative x and the sign is only different.
Sign's the only difference. So if you have the right terms and your sign's the only difference, what do you think you forgot to do? Factor out the negative, right? So even if you do everything the right way, you should be able to see your mistake because those parts won't match. And you know you're not completely off because your terms are the same. The fact that you have an x and the fact that you have a 2, right at this point, regardless of the sign, you know your terms are matching up, right? So, basically, so what's one of our answers? Tony, what's one of our answers?
3x minus 4.
Oh, yeah. There we go. 1, 2. The parts in front. What's another one of our answers?